Okay, so in this video, we're going to talk about odd and even functions and how you can tell if a function is even or odd. It's important as you move higher up in math and you start to graph more and more complicated functions. It's very useful in certain situations to know if a function you're trying to graph is even or odd, mainly because of the symmetry that even and odd functions have. So let's start with even functions. A great example of an even function is just f of x equals x squared, your basic parabola. And we call them even when they have symmetry about the y-axis. So recall what that means. Symmetry about the y-axis means if you looked at the right half of the parabola and you folded it around the y-axis, you would get exactly the same, the left half. More specifically, and this is our definition of an even function, what makes something an even function is if you evaluate your function at the negative of an x value, you get exactly the same thing as the value of your function at the positive x value. And that's very clear for x squared. Here are some points we know that go through f of x equals x squared. If x is 2, 2 squared is 4. So notice that f of negative 2, which would be over here, the value of the function at negative 2, which is 4, is exactly the same as f of positive 2. F of negative 1 is exactly the same as f of positive 1, and so forth. That's true for every x value. And so that's what the definition says, that's what makes this an even function, if this is true for all of your x values. It's very easy to see graphically, right? When a function's even, you can see that symmetry. Even though possibly in pre-calc you haven't started talking about trig graphs, it's never too soon to start, and we will soon be getting into trig functions. And I wanted to show you why it can be useful to understand if a function's even or odd. I'm just going to go ahead and tell you that cosine of x, that graph is an even function. And the right half of the graph looks like this. It actually passes through the point 0, 1, comes down, passes through pi over 2, 0, and pi negative 1. There's more to it, but that's just part of the graph of cosine. But if this is an even function, then we should be able to see the left half as being symmetrical. If you folded this over the y-axis, you would see that it's going to have symmetry, and it's going to look like this. And you could even pick out these points, right? If this gets reflected, this would be negative pi over 2, 0. And instead of pi negative 1, it gets reflected over here. This would be negative pi negative 1. So notice it's still true that f of, for example, negative pi over 2, the value of 0 is exactly the same as f of pi over 2. F of negative pi has exactly the same y value as f of positive pi, etc. So that's what makes it an even function. Sorry, getting ahead of myself, because the next thing to talk about is odd functions. Odd functions are a little bit trickier to see the symmetry. The way we usually describe it is we say odd functions have symmetry about the origin. And what does that mean, right? We'll get into that in a second. And the characteristic, it has a very similar definition. F of negative x will not be the same as f of positive x. It will be the opposite of f of positive x. So a good example of an odd function, f of x equals x cubed, that's a graph you should be familiar with, goes through some points here. We have 1, 1, because 1 cubed is 1, 2 cubed is 8, negative 1, negative 1, negative 2, negative 8. So let me first show you why this is true. So if looking at these points here, we can see that f of negative 1, which is right here, the value of that is negative 1. That's the opposite of f of positive 1. F of negative 2 turns out to be the negative or the opposite of f of positive 2. And so forth, right? So that fits the definition of an odd function. Now, what we mean by symmetry about the origin, it's kind of related to the even situation in that if you looked at the right half, you could generate the left half by first reflecting, you could do it either way, first reflecting this part around the y-axis. That would almost look like a parabola, and then taking that and reflecting it about the x-axis. So when we say symmetry about the origin, we mean the left half is the right half reflected about both the x and y axis, x and y axes. That's what we mean by symmetry about the origin. So to show you what I mean by that, here is the graph of another trig function, sine of x. It's starting at 0. There's more to it, but it kind of looks like this. There's more to it. It goes further on in that direction. But I'm going to go ahead and tell you that this is an odd function. So if it's an odd function and I wanted to sketch the negative part over here, what I first imagine is reflecting this mountain over the y-axis. So that would maybe look like this. I don't want to write it too dark. So that would look like this. And then reflecting that over the x-axis. And so what you would see is something like that. And yeah, instead of pi over 2, 1, because we know it's an odd function, f of negative pi over 2 should be the opposite of f of positive pi over 2, which means this point right here is going to be negative pi over 2, not 1, but negative 1. Okay, this point is negative pi 0. All right, so that's what an odd function is. Now, it's also important to recognize not every function is even or odd, right? It doesn't have to be even or odd. You can have functions that don't have that kind of symmetry. But if they do have either symmetry about the origin or symmetry about the y-axis, it's often useful to know that when you're graphing. It's not too hard now to see from the graph if a function's even or odd, but more often than not, what you'd be expected to do is, what if you had an equation of a function? How is it possible to know if an equation of a function is odd or even without the graph? And the answer is you can use the definitions of an even and an odd function. So for these problems, we're going to decide if these functions are odd, even, or as I said, they don't have to be. They can be neither. So let's start with this first one. If you look at the definitions for even and odd, notice that they both involve what happens if you plug in negative x. So let's see what happens. If I plug in negative x for each of those x's, and simplify it, we know that if you took a negative number, raised it to the 6th power, that would be exactly the same as positive x to the 6th. So I could just write that as 3x to the 6th. Same thing with a negative number to the 4th. That's going to be exactly the same as positive x to the 4th. 1 stays there. And notice when I substituted in negative x and simplified it, that is exactly f of x. So I have shown that f of negative x gives me exactly f of x. And if you look back at the definition, that is exactly what we mean by an even function. This function is even. Okay, let's try that here. F of x equals 2x to the 5th plus 4x. Let's see what happens when we plug in negative x. Well, this time, if you take a negative number, raise it to the 5th, it's still going to come out to be negative, right? So I know this is going to be negative x to the 5th. I'm going to go ahead and bring that negative out in front. So it would end up being negative 2x to the 5th. And if I bring this negative out in the front, that's going to be minus 4x. So clearly, that's not the same thing we got, right? That's not f of x. So we know it's not an even function. If I factor out that negative, 2x to the 5th plus 4x, I can see that this is in fact negative. And what was this? That was my original function. This is negative f of positive x. So f of negative x equaled the opposite of f of positive x. That is the definition of an odd function. Okay, So, and some, you might look at this and say, well, hey, makes sense. Both of these powers were odd powers of x, and it's an odd function. Both of these were even powers. That's an even function. That can be true. You do have to be careful, though. I've got some examples to show you why that may or may not tell you whether it's an odd or an even function. You do want to use the definitions. So here's another one. This one's a fraction. Let's see what happens if we plug in negative x. Well, taking a negative number and cubing it is going to be the same as negative x cubed. Here, taking a negative and squaring it is going to be exactly the same as positive x squared plus 1. And if I take that negative, I could always bring it out in front. I'm just really just trying to emphasize this, that if I bring that negative out front, this was what I started with. That is f of x. So once again, I was able to show that f of negative x is the opposite of f of positive x. So this is another odd function. Okay, x to the 7th minus x to the 10th. Let's see what happens. Plug in negative x. Here you've got an odd power, so a negative number to an odd power is going to come out to be negative. A negative number to an even power like 10 is going to be positive, but there was a negative in front, right? So this is going to be minus x to the 10th, right? That's positive, but there was a negative there. Now you got to be careful. That almost looks like you would say, hey, that's the negative of what I started with, right? But we've got to be a little bit careful. We could do like what I did earlier. Let's factor out a negative because we really want to show that it's the negative of exactly what we started with. So if I took out the negative there, this would be x to the 7th. But if I force out a negative, that's going to be plus x to the 10th. And you can see that this is not, right? That's not what we started with. So this is not the negative of f of x. And it's not the same as f of x. So this goes under the category, it's not even, it's not odd, so it must be neither. There is no symmetry, at least not around the y-axis or about the origin for this function. And maybe not surprisingly, well, I took an odd power and an even power, so it's maybe not surprising that this is neither. But here is my last example. This is where you got to be careful. So my function is x to the 9th plus x cubed plus 1. You might look, hey, I've got just odd powers. This should be an odd function, but let's make sure. Let's check. Both of these are to odd powers when I plug in negative x, so they will both come out to be negative. But kind of similar to the last problem, in order to show that this is really the negative of f of x, I would have to factor out this negative, and that would give me x to the 9th plus x cubed. But if I have to take out the negative, I've got to take it out from the whole thing. That would make this minus 1, which means this is not the same as this, huh? It is not the opposite of f of x. So this is another situation where it is neither even nor odd. All right, hopefully this has helped you understand what we mean by the even and odd function and how to show if a function's even or odd. Thanks for listening.